So last week we were learning about waves in the context of sound. This week I want to look at waves again, but in the context of light. And there will be a few lessons on how light behaves over the coming weeks. By the end of this video, I'm hoping you'll be able to describe how we see things, what happens to light when we see things, where light comes from, and describe how light behaves when it passes through or doesn't pass through different types of material and the words we use to describe those types of materials. So where does light come from? Well, light is emitted from objects which are known as luminous objects. And a luminous object is one which emits light for itself. So most objects will reflect light, but they don't emit light themselves. So things like a light bulb, the sun, a candle or a flame all emit light. So how do we see things? Well, this diagram illustrates the point. Light starts from a luminous source and then it reflects or scatters from the object we're trying to look at and then enters our eyes, and the lens in our eye focuses the light to create an image on our retina. We're going to learn more about lenses in a future lesson. So I used the phrase reflects or scatters. What's the difference? Both result in us being able to see things, but we see things in a slightly different way depending on whether it reflects or scatters. So on the left hand side you'll see a flat surface. Light is striking the surface and reflecting off, and you'll notice that the rays of light are remaining parallel and in the same order after they've reflected compared to when they came in towards the material. The material on the right has a rough surface, and instead of reflecting off and staying in the order, the rays of light are reflecting and going in random directions. So that's what we call scattering. So in the first example on the left, you would see a reflection of whatever it was producing the light. In the second example, you wouldn't see an image. You'd see light, you can see the object. So if this was paper, for example, then you'd see the paper, but you wouldn't be able to see the light bulb that created this light. If this was a mirror, then you'd see a picture or an image of the light bulb in the mirror. Why do we use arrows? So I've drawn some circles. These represent water waves. I'm sure most of you have thrown a stone into water or put your finger in a bowl of water or something and noticed that ripples spread out in a circle from the point where the stone hit or your finger went in the water. If we look at it from the side, then you get the wave pattern that you saw in previous lessons, corresponding to the peaks and the troughs of the water waves, the ripples that are spreading out. And the waves are travelling in all directions, which is why it's a circle. So the waves at this point are travelling in this direction, the waves at this point are travelling in this direction, the waves at this point are travelling in this direction, and so on and so on and so on. So the arrows represent the direction the wave is travelling. Now, of course, not all waves are circular. Water waves on the sea are straighter. They're not completely straight necessarily, but they are straighter. But the same principle applies. The arrows that we draw represent the direction of the waves. Okay, and again, if you look at it from the side, you end up with the wave shape that we recognise. When light hits an object, it can do one of three things. It can either reflect or scatter, that we've already talked about. It can be transmitted, go through it, or it can be absorbed. Now in reality, a combination of all of those things happens, generally speaking. So what do I mean by absorbed? Right, so in the case of regular glass, very little light is absorbed and most of the light passes through. We could assume so much of it is passed through that actually none of it's absorbed. In reality, some will be, but very little. But if I replace that with a darkened glass, maybe sunglasses, or tinted windows in a car, then more of the light is absorbed and less of it gets through. The energy that wave of light was carrying is also absorbed, and so the object will get slightly warmer. Its temperature rises. In terms of reflection, so a highly reflective object, most of the light, if not all of the light, is reflected off it, whereas a darker surface absorbs some of the light, that's why they look dark, because some of the light that strikes them is absorbed and not reflected, whereas bright objects reflect most of the light and absorb very little. This leads us to another 3 keywords we need to know about. First one being opaque. So if I shine light on something which absorbs most of the light or reflects most of the light and none of it passes through, we call that opaque. So opaque objects and none of the light passes through. So if I try and have a look at something, there's a picture behind there you can't see, because we're looking at it through an opaque piece of material. So cardboard, paper, metal. Transparent means that the light passes through, but it passes through in a way that we can see the object behind. You'll notice the rays of light pass through and stay in order. So the object is clearly visible when we look at something through transparent materials. Examples: glass, thin layers of water. When you've got thick layers of water, it's less transparent, but sort of like a beaker of water would easily be transparent. Certain plastics are transparent. And the last word is translucent. So translucent materials allow light to pass through, but because of the rough surface, scatter the light, and so you can't recognise what is behind it. The image is distorted and unrecognisable. So when I look at an object through translucent material, it's fuzzy or blurred or strange shapes, and it's difficult to tell what it is. Now in this case, obviously, you can easily tell that's a smiley face, but this is a mock-up, this isn't a real thing, so it's not really a good example. We might use glass that was translucent in bathroom windows, for example, so you can't see people when they're in the shower. But also it's used around light bulbs sometimes to spread the light further rather than be less harsh. That's why we use lampshades to a certain extent as well, so that it's a bit more flattering, a bit more pleasant light than if we just used a bare bulb. Final part for this lesson then, how are shadows formed? So we've seen that light is emitted from luminous objects. I've got in this case a candle. It's emitting rays of light in all directions, but I've only drawn a few that are going to be meeting the screen. Over on the right hand side we've got a screen, maybe a piece of paper. Candle, rays of light are hitting that, illuminating it. So we've got an object here which is an opaque object, maybe a piece of cardboard, which is blocking the rays of light. The rays of light can't pass through the opaque object. So rays of light which are passing the edge of the object here hit the cardboard, and all the ones above it hit the cardboard, and similarly rays of light here hit the cardboard, and all the ones below it hit the cardboard, but the ones in between those can't get through, and so there's a black area or a darker area here where none of the rays of light can pass through, and the shadow is formed. So to work out the position of the shadow, we use the fact that light travels in straight lines, and we draw those two rays in to give you the top and the bottom of the shadow. So that concludes this video.